Hi everyone, myself Dr. Lakshmi Prasad, working as a professor in the Department of Computer Science and Engineering at Institute of Aeronautical Engineering, Hyderabad. So in this video, I'm going to discuss about different kinds of graph. So basic definition is that graph is nothing but a generalization of the simple concept of sets and then dots, links, edges, and lines. So normally the graph is going to be defined as a set of B, E. So where B is going to be represent the set of vertices and E that should be denoted by capital letter B are going to be represented as V of G. And similarly the edge E is going to be represent the set of edges here. So the generation of this simple concept of the dots, links, and edges are nothing but arcs, and this one is going to be represented in the form of sets of vertices and then edges. So when it comes to the basic concept of this graph, so graph is defined as an ordered pair of set of vertices and edges and should be denoted as normally G equal to B comma E, and where V should be the set of vertices and E should be the set of edges connected between the vertices. And in the simple in the graph, so what I'm going to do is that uh, so in this graph, so the vertices should be A, B, C, D, E, and then edges should be A, B, A, C, B, D, C, D, and then D. So these all will be the set of vertices and then edges. So when it comes to different types of graph, we are going to have so many types of graph like null graph and then trivial graph, non-directed graph, directed graph, connected graph, and then disconnected graph, and irregular graph, complete graph, cyclic graph, and then cyclic graph, uncyclic graph, acyclic graph, and then next one finite graph, infinite graph, bipartite graph, planar graph, simple graph, multi-graph, pseudo graph, Euler graph, and then Hamiltonian graph. So we are going to be have different types of graphs. So let's see one by one. So the very first thing is that null graph. So the graph whose weight set is empty is called a null graph. In other words, the null graph does not contain any edges in it. So in null graph, we are going to have only the vertices and which does not have any kind of edges in between them. So that should be graph what we call as null graph. So the graph whose weight set is empty is called as a null graph. In other words, a null graph does not contain any edges in it. And here, this graph consists of vertices and there is no edges in it. And since the edge set is empty, therefore it is a null graph. And next one is trivial graph. So the graph having only one vertex is called a trivial graph, and it is the smallest possible graph. So the graph which is going to have only one vertex, that should be called as a trivial graph. So the graph consists of only one vertex, there is no edges in it, and since only one vertex is present, therefore it is a trivial graph. And next one is non-directed graph. So non-directed graph means that the graph does not have any kind of directions where the edges should be have undirected graph. So this one what we call non-directed graph or undirected graph. So in other words, the edges of undirected graph does not have any kind of directions. So in this graph is going to have four directions and four undirected edges. And since all the edges are undirected, therefore it is a non-directed graph. And next one is that graph in which all edges are directed, it is called as a directed graph. In other words, all the edges of the directed graph contain some directions, and the directed graph also called as a diagram. So here this graph consists of four vertices and four directed edges. Since all the edges are directed, therefore it is a directed graph. So whenever the graph is going, the graph whose edges is going to maintain by the directions, so that the graph will be called as a direct diagram. And this graph consists of four vertices and four edges. And next one is weighted graph. So weighted graph is one where each edge has a cost for traveling between the nodes. And the weighted graph is one where the each edge has a cost for traveling between the nodes. And here what I'm going to say that, so whenever the graph is going to assign some weights for the edges, so the graph what we call as the weighted graph. And next one is connected graph. So the graph in which the where we can able to visit from one vertex to another vertex, then the graph is said to be connected. So whenever I'm going to reach from vertex B to vertex H, so okay, if I'm going to reach this from B to H, so then I can able to say this should be the connected graph. So in a graph, if I'm going to visit from one vertex to another vertex, so that the graph what we call as connected. So in connected graph, at least one path between exists between every pair of vertices. So this should be the example of multi-graph also. And in this graph, have at least one pair of vertices, therefore it should be a connected graph. And next one is the disconnected graph. So disconnected graph means a graph in which there does not exist any path between uh, them, and at least one pair of vertices is a disconnected graph. So whenever there exists a path, does not exist a path between one path of vertex and another pair of vertices, then I can say this should be the disconnected graph. So if I'm going to join, they should be connected ones. So since there is no exist path from the D to F, so that's why the graph what we got a disconnected graph. So this graph consists of two independent components which are disconnected, and it is not possible to visit one of the component to the vertices of the other component. So therefore, it should be a disconnected graph. So the graph is independent components which are disconnected one. So that graph what we called as a disconnected graph. And next one is regular graph. So regular graph means a graph in which the degree of all vertices should be same as same. That's why what we called as a regular graph. So if I'm going to consider this graph, so the degree of this graph is 2, here is 2, and here is 2, and here is 2. So the degree of all the nodes of the graph is 2. So what we call that we should be have regular graph. So if all the vertices in the graph is going to have a degree k, then it should be called as a k-regular graph. So here all the vertices are going to have the degree 2. So therefore they are k-regular graph. And what is this? Next one is that complete graph. So graph on which exactly one edge is present between every pair of vertices is called complete graph. So complete graph n of one vertices exactly. So that's when we're going to have MC2 edges. So a complete graph of one vertices is repeated at An. Normally this one is going to be have K3, and here the number of vertices in the graph is 4, that's why K4. So here the edge vertex is connected with the remaining vertices to exactly one position, and therefore completely graphs here. And this one is that cycle graph. So cycle graph means a simple graph of n vertices and edges is going to form the cycle, and the length of n is called cycle graph. So all the vertices of the graph will be n by 2. So a simple graph of n vertices of forming a cycle means we should have 3. So in 3 we are going to construct a cycle, and then 4 also going to form a cycle, and then when we construct 5 it should also form a cycle. So here the only vertex should be 2, So this should be the cyclic graph. So what is this cyclic graph? So graph containing at least one cycle. So if a normal graph is going to have more than one cycle, so then it is called as a cyclic graph. So here the graphs contain two cycles, and therefore it should be a cyclic. And next one, what you want called as a acyclic graph. So a graph not containing any kind of cycle, that should be a cyclic graph, and here the graph does not contain any cycle name, therefore it should be a cyclic graph. So if I'm going to join these vertices, then this graph should also become green graph, and here what we call it as. So a graph containing not containing any kind of cycle is a cyclic graph, and the example is given. And here the graph does not form any cycle, therefore it should contain a cyclic graph. And next one is bipartite graph. So what is a bipartite graph? So a bipartite graph is a graph where the vertices are going to be divided into two or more sections. So on these vertices of the so you can join the vertex of the set X only joining the vertices of set Y. So the none of the vertices become to the same as set join with each other. So if I'm going to have the set, this is considered one set and this is considered another set. So when I'm going to join a vertex from vertex of one set to the vertex set of another set, then this graph what we call as isolated graph. So what is the next one is planar graph. So graph which is going to on a plane, so such that no two edges should be intersect each other. So whatever the graph of one set, the two edges may not be intersect each other. So that kind of what we call as a planar graph. So we are unable to draw in a plane. And next one is pseudograph. So pseudograph means that a graph whose parallel edges, no parallel edges, but having the side loops. So what we call as pseudograph. So in a graph which is going to have a simple and then white self loop, what we call as this. So the graph is not maintaining self loops but not maintaining parallel edges, then it should be pseudograph. And next one is simple graph. So simple graph means a graph which is going to have no self loops, edges. So that's why it's simple graph. And what is this multi-graph? So graph with no self loop but is going to have parallel edges. So that's why what we call it as a multi-graph. So whenever the graph is going to have, it does not forms a planar or simple graph. So when I'm going to maintain this single loop, then it should be what we call it as pseudograph. And if I'm going to maintain both the multiple edges and the planar loop, what we call it as a pseudo. So each graph consists of two, three vertices and four edges. So all vertices should be same as the angle side. So the no boundaries are going to be defined by constructing this multi-graph. And next one is that Euler graph. So Euler graph is a connected graph in which all the vertices should have even degree. So the degree of all the vertices is even, therefore it should be Euler graph. And next one is Hamiltonian graph. So Hamiltonian graph means if there exists a closed path that is going to be connected that visits every vertex of the graph exactly once. So without repeating the edges, then the graph what we call as Hamiltonian graph. So if there exists a closed path connected, then that visits every vertex of the graph exactly once. So without repeating the edges, so such graph what we call as Hamiltonian graph. So remember these points of the different graphs. So if I'm going to consider a simple graph, graph means they may have some edges, self loops, and parallel edges. Okay, so if I'm going to consider simple graph means no loops are going to be considered and no parallel edges. A multi-graph means that if I have no parallel edges and no multi-graph, the parallel edges should be there and then no self loops. And pseudo graph means both edges but no self loops. So these are the differences between the different kinds of graph here. So simple graph means both the loops and parallels will be there, and pseudo graph means only the self loops, and simple graph means no self loops and no other, and multi graph means this one. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.